Guys, just give me a second. Let me fix certain things. Just a second, okay? Just a second. All right, people. So good evening, and welcome back again to your Unacademy NEET English channel. I hope all of you are doing great, having a good time. So, my dear students, quickly let me know in the chats if all of you can hear me, if I'm perfectly audible and visible to everyone. Let me know quickly in the chats if all of you can hear me, if I'm perfectly audible, visible to every one of you. Quickly, people, in the chats. Loud and clear? Yes. So today, my dear students, it's going to be the top 100 most expected questions of your physical chemistry. Okay? The duration of the session will be 2.5 hours. Around that. I would want you guys to call up all your friends because the session is extremely important, because the questions in your NEET examination will be directly, indirectly from these sort of question patterns which I'll be showing you in the session. Okay? All right. So before starting this particular session, the thing which I keep on asking you in every session, what is that? Which part of the country you guys are watching me from right now? I just want to know first. Which part of the country you guys are watching me from right now? Quickly. Sir, why don't you go with one shot of each chapter? That's already taken on this channel. You can go to the playlist, you'll get everything. Quickly, people in the chats. Everyone. Everyone. I want the chats to be running. Okay, Tamil Nadu, Rajasthan, Earth, Manipur, Andhra, Karnataka, West Bengal, Tamil Nadu, Kerala. All right. Maharashtra, Shillong, Kashmir, Punjab, Kolkata. And I want to know. I want to know. UP, Meghalaya, Nagaland, and Anantnag. Okay, nice. Nice. All right, all right, all right. From your heart. Wow. Yeah. My doctor has prescribed me to have the lukewarm water sips in between, because you know my throat is not in a great condition. Yeah. So guys, are you all ready for the session then? Should we start? Should we get going? Trust me, you are going to learn a lot of things in today's session. A lot of things, guys, a lot of things. And at the same time, the PDF of this particular session, I'll be sharing on my Telegram. I hope you guys are already the part of my Telegram channel. If not, be the part of my Telegram channel as soon as possible. The name of the Telegram channel is Wassim Bhat Chemistry Official. WASSIM BHAT Chemistry Official is the name of the Telegram channel, on which I'll be sharing the handwritten PDF of the today's session as well. Okay? And be ready with your pen and paper as well, because you will have to solve a lot of questions today. You'll have to solve, right? It's physical chemistry, so it takes time to solve, right? I hope you all are ready with your pen and paper. And my dear students, before starting the session, I need to show you something very, very, very important. What is that? See, I don't know whether you guys know it already or not. This session is going to be extremely important. This session is going to be extremely important. Which session this is? In one marathon, I will be taking your class 11th complete chemistry. On Saturday, 9 a.m. Okay? Saturday morning, 9 a.m., I'm going to take a session in which I shall be discussing your complete class 11th chemistry in one stream, in one session. Be the part of this particular session. Complete class 11th chemistry I'll be doing, right? And the ones who have not smashed the like yet, do smash the like right now, right? And do not forget to click on notify me as well, because that's how you remain updated about this particular session. Okay? All right? Perfect. So let's get going. Let's get started with the top 100 most expected questions of your physical chemistry. Right, people? So let's get going. Let's get started, my dear students, with the first question, which is on your screen. The first question, which is on your screen. Look at the question carefully. I want the chats to be running continuously, okay? I want the chats to be running continuously today. The question says 1 atomic mass unit, 1 AMU, is equal to. If you do not know, let me tell you, this question is from the chapter mole concept. So first I'll be starting with the questions of mole concept, and let me tell you, 1 atomic mass unit is nothing but 1.66 into 10 raised power minus 24 grams. Okay, this is the answer of the first question. If you do not know it yet, remember from now onwards, 1 AMU is nothing but 1.66 into 10 raised power minus 24 grams. So it is option B that is the correct answer of this particular question. Okay, number 1. Number 2, my dear students. Number 2. What mass of sodium chloride? What mass of sodium chloride would be decomposed by 9.8 grams of sulfuric acid? What mass of sodium chloride? What mass of sodium chloride would be decomposed by 9.8 grams of sulfuric acid? 9.8 grams of sulfuric acid. 9.8 grams of sulfuric acid. If 12 grams of sodium bisulfate, if 12 grams of sodium bisulfate, if 12 grams of sodium bisulfate and 3.65 grams of hydrogen chloride is produced. Okay, I wrote the reaction. What mass of NaCl is required, right? I have to calculate the mass of NaCl. Now, if you are thinking that I'll be using stoichiometry, etc., you are doomed. Okay? You just have to use one simple concept, my dear student. Law of conservation of mass. What law of conservation of mass says? Law of conservation of mass says that the total mass on the reactant side has to be equal to total mass on the product side. That's it, right? Let the mass of NaCl participated in the reaction is x grams. So mass of reactants will be x plus 9.8. Total mass of products will be 12 plus 3.65. Do you see? You got one equation that contains one unknown x. So you can easily calculate x. It is 12 plus 3.65 minus 9.8. Right? The answer is going to be this one. Now do the calculation and get the answer. As simple as that. Right? Perfect. A simple question based on law of conservation of mass. Right? Simple. Total mass on the reactant side has to be equal to total mass of the product side. That's all. Nothing more, nothing less. Got it? Perfect. So when you solve this particular thing, you'll be getting the exact value as 5.85 grams. Perfectly done. My dear students, moving on to the next question. A simple question this is again, right? And I believe you can easily solve this. Look at the question carefully. The question is the number of atoms in 0.1 moles of a triatomic gas. Right? Triatomic gas, my dear students. Triatomic gas, for example, you have got a triatomic gas like this, A3. Let's say this is a triatomic gas. Like you have got ozone, O3. That's a triatomic gas. You have got CO2. That's a triatomic gas, right? Let's say the gas is O3. As far as the question is concerned, we are given with 0.1 moles of triatomic gas. So number of moles of A3 is equal to 0.1. What do we have to calculate? Total number of atoms. That's it, right? So I'll be first of all multiplying moles with the Avogadro's number. I'll be getting the molecules. So these are the molecules of A3. These are the molecules of A3. But as per the question, am I supposed to calculate molecules? No, I am supposed to calculate atoms. You tell me one thing. One molecule of A3, if I talk about one molecule of A3, one molecule of A3 contains 3 atoms. If one molecule of A3 contains 3 atoms, I would say 0.1 Na molecules will be containing 3 into 0.1, which comes out to be 0.3 Na atoms. Am I clear with this? Now you can put the value of Avogadro's number here, 6.022 into 10 raised power 23. Multiply that with 0.3. The final answer which you'll be getting, that will be option number B. Okay? As simple as that. Perfectly done. I just multiplied the moles with Avogadro's number, I got molecules. Then I saw one molecule of A3 contains 3 atoms. So 0.1 Na will contain 3 into 0.1 Na atoms. Okay? Moving on to the next question, people. Moving on to the next question. Moving on to the next question. Look at this particular question carefully. One atom of an element weighs 6.6 into 10 raised power minus 23 grams. Number of moles in 20 kg. Number of moles in 20 kg. Have a look, people. So as far as the question is concerned, imagine this your container. In this container, you have got 20 kg of element X. Now tell me, 20 kg means 20,000 grams. So basically in the container, you have got 20,000 grams of X. I have to calculate how many moles. I have to calculate how many moles of X are there. So number of moles of X will be equal to given mass of the X in grams divided by molar mass of X. Simple. I'm given with mass. I need to calculate moles. So given mass divided by molar mass. So number of moles of X is equal to what is given mass? That is 20,000 divided by. I do not know the molar mass of X. I do not know the molar mass of X, but we can calculate molar mass, right? Remember, my dear students, molar mass of an element is nothing but, it is equal to mass of one atom of an element. Molar mass of an element is nothing but, it is mass of one atom of an element in grams multiplied by Avogadro's number. This is how you calculate molar mass. This is how you calculate molar mass. So if the mass of one atom is given, you just have to multiply that with Avogadro's number. You'll be getting the molar mass, right? Now, molar mass of X is equal to, what is the mass of one atom? Mass of one atom of X is 6.6 into 10 raised power minus 23 grams. Multiplied by Avogadro's number, 6 into 10 raised power 23. So this term gets cancelled out. This will be 36. Approximately, it will be 40 grams. Approximately, it will be 40 grams. So I got the molar mass of X. If I got the molar mass of X, so I can divide the given mass with the molar mass, which came out to be 40. So the value comes out to be how much? It will be how much? 500. Perfect. It will be 500. Perfectly done. So that means in this container, we have got 500 moles of X. I hope this particular question is beneficial. So the question was simple. Given mass by molar mass, but you were not given with the molar mass. You had to calculate molar mass. How? Mass of one atom multiplied by Avogadro's number. Perfectly solved. I believe this is clear. Okay. One simple question. But I know a lot of students will also do a mistake here also. See guys, number of atoms of helium in 100 U of helium. So, 100 U of helium, right? We are given with 100 U of helium. I need to calculate how many atoms are there. How many atoms are there in 100 U of helium? I need to calculate how many atoms are there in 100 U of helium. If I ask you what is the atomic mass of helium, your answer should be 4U. Atomic mass of helium is 4U. So can I say 4U is nothing but the mass of one atom of helium, right? If 4U is the mass of one atom of helium, use the unitary method, I can say 1U will be the mass of 1 by 4 atoms of helium, right? If 1U is the mass of 1 by 4 atoms of helium, so 100U will be the mass of 1 by 4 multiplied by 100. That comes out to be 25 atoms. So the mass of 25 atoms of helium is nothing but 100 U, right? Option B is the one that's correct. Is this clear? Moving on to the next question. Look at this particular question. What do you think about this one? What do you think about this one? What do you think about this one? Everyone in the chats. What do you think about this one? Quick, people, quick, everyone. The question is, insulin contains 3.5% sulfur. Insulin contains 3.5% sulfur. Khalid Bilal sir, asal palm question kar rahe ho. Kal se jigar god wants me answer. Okay, insulin contains 3.4% sulfur. What will be the minimum molecular weight of insulin? These are the frequently asked questions. If you would have seen the NEET papers. Quick, people. Quick. See, as far as the question is concerned, you are given with the compound insulin. You are given with the compound insulin. And in insulin, mass percentage of sulfur is given. Mass percentage of sulfur is given. How much is that? 3.4%. Mass percentage of sulfur in insulin is given. What do I need to calculate? I need to calculate the minimum molar mass of insulin. I need to calculate the minimum molar mass of insulin. What do I do? How do you first of all calculate the mass percentage? I hope you know the formula. Mass percentage of element is nothing but it is molar mass of element multiplied by Z divided by molar mass of compound multiplied by 100. This is the formula to calculate mass percentage of an element, right? Now, my dear students, instead of mass percentage of sulfur in insulin, I can write molar mass of sulfur, that is 32, multiplied by, what does this Z indicate? Z indicates the number of sulfur atoms in insulin. The number of sulfur atoms in insulin, right? Z indicates the number of sulfur atoms in insulin. Now, my dear students, we are supposed to calculate minimum molar mass of insulin. Whenever you are supposed to calculate minimum molar mass, whenever you are supposed to calculate minimum molar mass, take the Z value as 1. Take the Z value as 1, divided by molar mass of compound, that means molar mass of insulin, multiplied by what? Multiplied by 100. This value as per the question is 3.4. Now, if you do the cross multiplication step, molar mass of insulin will be coming out to be 900 something. If you do the cross multiplication and stuff, molar mass of insulin will come out to be 900 something. So I believe 941 grams is the correct answer. Okay. Again, a simple question based on the formula. Nothing more, nothing less. Moving on to the next question. Moving on to the next question. In these sort of questions, you make frequent mistakes. What do you think about this one? Quick. What do you think about this one? Quick. Every one of you. Every one of you people. See guys, the number of gram molecules. So first of all, what is meant by gram molecules? Gram molecules means moles. Gram molecules means moles of oxygen. Since they have mentioned gram molecules, so I'll consider oxygen in the form of O2. If they had mentioned gram atoms, then I would have considered oxygen as O. Right? Right? Look here now. The number of gram molecules, the number of moles of O2 in 6.02 into 10 raised power 24 carbon monoxide molecules. So first of all, my dear students, these are the carbon monoxide molecules which are given to me. So let me see first of all how many moles of carbon monoxide we have. It is given number of particles. Given number of particles divided by Avogadro's number. Right? The value is 10. So technically we are given with 10 moles of carbon monoxide. Technically we are given with 10 moles of carbon monoxide. I have to calculate the number of moles of O2 which are present in 10 moles of carbon monoxide. How do I do it? Have a look. I can say 1 mole carbon monoxide contains 0.5 moles of O2. 1 mole carbon monoxide contains 0.5 moles of O2. If 1 mole carbon monoxide contains 0.5 moles of O2, therefore 10 moles of carbon monoxide will contain into 10, the value comes out to be 5 moles of O2. Or instead of 5 moles of O2, you can write 5 gram molecules of oxygen. 5 gram molecules of oxygen. So the answer is 5. Be careful with these questions. Be careful with these questions, right? They look simple, but you make mistakes in these questions only. Yeah? Perfect. Right, people? I believe I'm clear with this. If I'm clear with this particular question, tell me, what do you think is the answer of this question? Tell me what is the answer of this particular question. Quickly. The question is again simple, but you make mistakes in these sort of questions. And this is the level of your NEET, by the way. Okay? See guys, 3.011 into 10 raised power 22 atoms of an element weighs 1.15 grams. The atomic mass of the element is. How do we deal with this? Understand? Understand, people? So first of all, 3.011 into 10 raised power 22 atoms have got the mass of 1.15 grams. Therefore, if I use the unitary method, what will be the mass of one atom? Mass of one atom will be 1.15 divided by 3.011 into 10 raised power 22 grams. This is the mass of one atom. If this is the mass of one atom, therefore, the mass of 6.022 into 10 raised power 23 atoms will be how much? 1.15 divided by 3.011 into 10 raised power 22 multiplied by 6.022 into 10 raised power 23 grams. When you do the calculation, the value will come out to be 23 grams. So what is this 23 grams? What is this 23 grams? This is the mass of 6.022 into 10 raised power 23 atoms. That means this is the mass of 1 mole of substance. This is the mass of 1 mole of element. This is the mass of 1 mole of element. And the mass of 1 mole of element is what you call as molar mass. So molar mass of element came out to be how much? Molar mass of element came out to be 23 grams. If molar mass of the element is 23 grams, so what is going to be the atomic mass? Atomic mass will be simply 23 AMU. Atomic mass will be simply 23 AMU, right? So the answer is what? 23. Am I clear with this? Right? Now, sometimes they'll ask you the question, identify the element. Identify the element. So which element has got the atomic mass of 23 AMU? That is sodium, right? So the element has to be sodium. Perfect. All right. Moving on to the next question, people. Moving on to the next question. What do you think about this one? Again, looks simple. Looks simple. Let the molar mass of element is equal to A grams. Let the molar mass of element is equal to A grams. The mass of 10 atoms of element will be. Simple question. Give it a thought. See, molar mass of the element is given. Molar mass of the element is given as A grams. If molar mass of the element is A grams, that means atomic mass of the element will be how much? AMU. You just have to change the units. If molar mass of the element is A grams, atomic mass of the element is AMU, which means that mass of one atom, which means that the mass of one atom is equal to how much? AMU. If the mass of one atom is equal to AMU, therefore, as per the question, what would be the mass of 10 atoms? If the mass of one atom is equal to AMU, mass of 10 atoms will be 10 AMU. Do you see any option like this? 10A. Option C is the correct answer. Simple, basic, right? To the point. All right, moving on to the next one. This sort of a question you would have solved many a times, right? This sort of a question you would have solved many a times. Chlorine exists in two different isotopic forms. So I am given with chlorine. It has got two isotopes. One is Cl35, one is Cl37. Cl35, one is Cl37. This indicates the ratio of Cl37 and Cl35 is approximately. See, how do I deal with such kind of the question? My dear students, as far as the question, the average atomic mass of chlorine is given to me as 35.5, right? I have to calculate percentage abundances of its isotopes. I have to calculate the percentage abundance of its isotopes. Let the percentage abundance of this isotope is X. So this is going to be 100 minus X. This is going to be 100 minus X, right? Perfect. Now, my dear students, this is what I'm calling as M1. This is what I'm calling as M2. This is what I call as A. This is what I call as B. Now, I have the formula to calculate M average. That is M1A plus M2B divided by A plus B. That's 100. And as per the question, this value is nothing but 35.5. Now, put the values. M1 is 35. A is X. M2 is 37. B is 100 minus X. Right? Divided by 100 is equal to 35.5. When you do a calculation, X value will come out to be 75%. If X is 75%, that means the abundance, the mole percentage of this isotope is 75%. So this will be automatically 25%. right? So the ratio is going to be, this is going to be 1, this is going to be 3. So the ratio is going to be 3:1. But are they asking the ratio of Cl35 is to Cl37? No, they're not asking the ratio of Cl35 is to Cl37. They are asking the ratio of Cl37 is to Cl35. Cl37 is to Cl35. So the answer is 1:3. The answer is 1:3. I believe this sort of a question, again, you would be in a position to solve. Right? Perfect? Perfect, people? One simple question. What do you think about this one? Everyone should at least solve this one. It's a simple one. It's not difficult. The question is the percentage of oxygen in CH2O. We have to calculate the mass percentage of oxygen. Mass percentage of oxygen will be equal to. How do I calculate the mass percentage of element in a compound? How do I calculate mass percentage of element in a compound? Few minutes back I gave the formula. Molar mass of the element multiplied by Z divided by molar mass of compound multiplied by 100. This is the formula. What is the molar mass of oxygen? You know that's 16. What is the Z value? How many oxygen atoms do you see? 1. Divided by. What is the molar mass of this entire compound? This is 12. 12 plus 2 is 14, right? 14 plus 16 is 30 multiplied by 100. Again, matter of calculation and you are done. When you solve this, the answer will be 53%. Okay? What about this one, people? What about this one? What about this one? Quick. What do you think about this particular question? If you look at this particular question, calculate the minimum mass of Cl2 in grams required to produce 37.25 grams of KCl. So as per the question, we have to produce 37.25 grams of KCl, right? So technically, how many moles of KCl do we have to produce? Number of moles of KCl to be produced is equal to mass of KCl divided by molar mass of KCl. Molar mass of KCl is 74.5. When you solve, the answer is 0.5. So technically, as per the question, I need to produce 0.5 moles of KCl. I need to produce 0.5 moles of KCl. Now look at the stoichiometry. Here it is 1. Here it is 1. So can I say one just simple thing? Can I say 1 mole of KCl is produced from 1 mole of Cl2? Absolutely. If 1 mole of KCl is produced from 1 mole of Cl2, I would say 0.5 moles of KCl would be produced from 0.5 moles of Cl2, right? So these are the moles of Cl2. But am I supposed to calculate moles of Cl2 or mass? I need to calculate mass of Cl2. So mass of Cl2 will be equal to moles of Cl2 multiplied by molar mass of Cl2. The value comes out to be 35.5 grams. So this is something I was supposed to calculate. The answer is B. Got it? I hope this is also clear. If this is clear, people, have a look on this one. Have a look on this one. 20 grams of magnesium carbonate. 20 grams of magnesium carbonate. So we are given 20 grams of magnesium carbonate. Okay. 20 grams of magnesium carbonate decomposes on heating to produce 8 grams of carbon dioxide. To produce 8 grams, is it 8? No, there is nothing like that. It is 8 grams of magnesium oxide. Okay. So basically 20 grams of magnesium carbonate, when you heat it up, what do we get? We get 8 grams of magnesium oxide, and with magnesium oxide, we are getting carbon dioxide as well. The question says, what is the percentage purity of magnesium carbonate in the sample? What is the percentage purity of magnesium carbonate in the sample? So first of all, this is what I call as mass of impure sample of magnesium carbonate. How do I calculate percentage purity? Percentage purity of magnesium carbonate in the sample, as per the formula, will be mass of pure magnesium carbonate divided by mass of the impure sample of magnesium carbonate multiplied by 100. Correct? I am giving you the mass of impure sample of magnesium carbonate. That's 20 grams. What I need to calculate the mass of pure magnesium carbonate. How do I calculate the mass of pure magnesium carbonate? Try to understand very clearly what I'll be doing. Try to understand what I'll be doing. First of all, my dear students, what is the molar mass of this magnesium oxide? 24 plus 16, that is 40 grams. Correct? What is the molar mass of this magnesium carbonate? I think it will be 84 grams. 48 plus 12 is 60. 60 plus 24 is, 84 grams. Can I say, as per stoichiometry, 40 grams of magnesium oxide are produced from 84 grams of magnesium carbonate? Absolutely. Therefore, I would say 1 gram of magnesium oxide would be produced from 84 divided by 40 grams of magnesium carbonate. Absolutely. So as per the question, 8 grams of magnesium oxide will be produced from 84 divided by 40 multiplied by 8. 8185, right? So it comes out to be 84 divided by 5, which will be how much? Which will be 5.1, and this will be 5.6, right? So 16 point something. 16 point something, right? 16 point something grams. So if I ask you, what is the 16 grams? This is the mass of pure magnesium carbonate, which has participated in the reaction. If you got the mass of pure magnesium carbonate, which is 16 approximately, divided by mass of impure sample. Mass of impure sample was 20 grams multiplied by 100. Do the calculation, get the percentage purity. That's all. Right? That's how you calculate percentage purity basically. I believe you got to know how do we deal with such kind of the question. Now, moving on to the one more question, guys. Again a simple question. Use your brain a bit and tell me the answer of this question quick. Use your brain a bit and tell me the answer of this question quick. Quick, people. Everybody in the chats. Everybody in the chats. If you look carefully, the question says 0.44 grams of a colorless oxide of nitrogen occupies 224 ml at STP. So technically, as per the question, I would say 224 ml of the oxide has got the mass of 0.44 grams at STP, correct? If 224 ml has got the mass of this much, if I multiply with 100 on both the sides, can I say 22400 ml will have the mass of 44 grams at STP? I can say that, right? I can say that. 224 ml has got the mass of 0.44 grams. So multiplying 100 on both the sides. So I can say 22400 ml has got the mass of 44 grams. 22400 ml at STP means 1 mole of gas. So 1 mole of gas has the mass of 44 grams, right? Mass of 1 mole of the gas is what you call as molar mass of the gas. So I got the molar mass of the gas. How much? 44 grams. If you got the molar mass of the gas, so you can say molecular mass of the gas is equal to 44 AMU or 44 U. This is the molecular mass of the gas. Now check which of the following gases has got the molecular mass of 44. Which of the following gases has got the molecular mass of 44? I think it's N2O. Nitrogen, 14 into 2 is 28. 28 plus 16 comes out to be 44. Right? I believe this is clear. I believe it's clear, my dear students. Moving on to the next question. Moving on to the next question. Look at the question, guys. A carbon compound contains carbon and oxygen, has approximate molar mass equal to 290. On analysis, it's found to contain 50% by mass of each element. Therefore, the molecular formula of the compound is. So basically, you have got a compound that contains carbon and hydrogen. Is it carbon and hydrogen or carbon and oxygen? Okay, carbon and oxygen. Perfect. Well, as far as the question is concerned, mass percentage of these elements is given. This is 50%. Even this is 50%. Right? 50%, 50%. Correct? What is the first thing I'll be calculating? I'll be calculating the atomic ratio. How do I calculate atomic ratio? See, atomic mass of carbon is 12. This is 16. So it's going to be 50 divided by 12. This is going to be 50 divided by 16. Right? Can you do a bit of calculation quick? How much the value comes out to be? Quickly, people. 50 divided by 12. How much? 4 point what? Do a bit of calculation quick. Quickly, people. I think without solving also we can do this question. Without solving also we can do this question. I feel so. See, molar mass is already given. Calculate the molar mass of each. Check which is matching. Right? So let me not do all this procedure and all. Yeah? Do you understand? So you have to be somewhat smart also in the examination hall. Otherwise, you have to do this procedure. This will come out to be 4:3. Then you will calculate the empirical formula. Then you will calculate the molecular formula, etc., etc. Let's not do that. Options were given to me. right? Options were given to me. I just checked. There is only one molecule which has got the molar mass of 290. So this is option E directly, right? Perfectly done. Okay, this is again a simple question. This is again a simple question. The simplest formula, empirical formula, right? A compound contains X and Y. X has got the atomic mass of 10 AMU. Y has got atomic mass of 20 AMU. Their percentage is given to us as 50%, 50%, right? So atomic ratio will be this 50 divided by 10 will be 5. 50 divided by 20 will be 2.5. Which one is least among the two? 2.5. So divide both of them with that least number. So 5 divided by 2.5 is 2. 2.5 divided by 2.5 is 1. So the simplest formula is going to be X2, Y1. X2, Y1, right? A simple basic question this is. Let's move on to your redox. Chalo. Again, I want the chat section to move continuously. What is the answer of this one? This has been asked in NEET 2020. Just to boost up your confidence, I came up with this question as well. Okay, what is the change in the oxidation number of carbon in the following reaction? See, my dear students, if you look at carbon here, right? Calculate its oxidation state. How? Carbon has got the oxidation state of X. Hydrogen. What is the most common oxidation state of hydrogen? +1. How many hydrogen atoms? 4. Net charge is 0. So X value will come out to be -4. What is the oxidation state of carbon here? X. Halogen most common. -1 into 4 is equal to 0. So X is equal to +4. So the oxidation state of carbon is going from -4 to +4. So it is absolutely option number 2. Everyone? Guys, I want you to let me know the answers in the chats continuously. All right? Chalo. Moving on to the next one. Again, this is the NEET asked question. It's a PYQ. You know, a lot of questions are repeated from PYQs as well. And when it comes to redox, in redox, there are some selected topics from which questions will be framed, right? And first topic is oxidation state. Chalo, tell me the answer of this question. The oxidation number of the underlined atom in following species is given. Identify the incorrect option. If I look at all the options, I got the answer. Look at the second option, my dear students. Cu2O, right? Cu2O. Let's assume the oxidation state of copper is X. So this is going to be 2X. What is the most common oxidation state of oxygen? That's -2. Net charge is 0. So X has to be +1. So over here they have given as -1. So this is incorrect. Leave the other options aside. Right? Perfect. Guys, tomorrow at 7 p.m. I'm posting one very, very, very important video on this channel. Do watch that video. Tomorrow at 7 p.m. I'm giving you the complete schedule for 15 days. And trust me on that. If you follow that, right? I'm telling you what we are planning on this channel. If you follow that with 100% honesty, you can easily shoot up your ranks. Trust me on that. Because whatever is required at this particular point of time for a student, for a serious aspirant, all those things we are coming up with in these upcoming 15 days. So you have to be consistent. Okay? All right. Look at the next question, people. Did I move on to the next question? CrO6. Oxidation state of chromium. You should know the structure of CrO6. This is the structure of your CrO6. If you do not know, this is the structure of CrO6. And when you calculate the oxidation state of chromium here, it will be +6, right? +1, +1, +1, +1, +1, +1. So +6. Simple. No, it is not butterfly. Butterfly is CrO5. Butterfly structure is CrO5. That is something like this. This is CrO5. And here also its oxidation state is +6. This is butterfly like CrO5, not CrO6. Okay, moving on to the next one. These sort of questions are also frequently asked. So, check this question out. The question says, which of the following are disproportionation reactions? What is a disproportionation reaction? Have a look. For example, you have got the reaction like this. A2 gives A positive plus A negative. A2 gives A positive plus A negative. If I talk about the oxidation state of this A, it is 0 here. Here it is +1. Here it is -1. 0 to +1, increase in the oxidation state. 0 to -1, decrease in the oxidation state. 0 to +1, increase in the oxidation state. 0 to -1, decrease in the oxidation state. So I would say oxidation state of same element is increasing as well as decreasing. Whenever you see this scenario, in which the oxidation state of same element increases as well as decreases simultaneously, we say the species undergoes disproportionation. We say the species undergoes disproportionation. Now tell me, what do you think about this one? The question is pretty much simple. Here you have got copper positive. So it's +1, this is +2, this is 0. +1 to +2, increase. +1 to 0, decrease. Disproportionation. Increasing as well as decreasing, right? Here manganese, if you calculate its oxidation state, it will be +6. Here manganese, MnO4 negative, it will be +7. Here manganese will be in +4, right? +6 to +7, increase. +6 to +4, decrease. And again, disproportionation. Okay? Here manganese is already in maximum oxidation state, +7. So it cannot increase. Here also manganese is already in its maximum oxidation state, +7. So it cannot further increase, right? So 1 and 2 is going to be the correct one. 1 and 2 means option number 1. Got it? Guys, did you understand this question? I believe yes. Perfect. Similarly, my dear students, look at the next one. A simple question, right? In the question paper, you find 5 to 6 simple, basic questions like this, which you solve without using pen paper, right? I believe you can easily do it. What is the oxidation state of phosphorus here? When you calculate, it will be +5 because you know it is X -2 into 4 is equal to -3. Here it will be +6 in SO4 dinegative. In Cr2O7 dinegative, it will be +6, right? So this is something which we call as easy kill questions. And you get some almost 5 to 6 questions in the paper like this, right? Moving on to the next one, guys. Substance that is oxidized and reduced. Substance that is oxidized and reduced. If you look carefully, here you have got hydrogen peroxide. What is the oxidation state of oxygen in hydrogen peroxide? It is -1. What will be the oxidation state of oxygen here? It is -2. Water. -1 to -2. Decrease. Decrease means reduction. So this species is undergoing reduction. If this species is undergoing reduction, that means this species is undergoing oxidation. Simple. Substance that is oxidized and reduced. N2H4 is oxidized and H2O2 is reduced. So it's directly option number 2. Perfect, people? Perfect? All right. Calculate the N factor of ferrous oxalate in the following reaction. They can also ask calculate the equivalent mass of ferrous oxalate. You know, equivalent mass is nothing. Equivalent mass is equal to molar mass divided by N factor, right? If you know the N factor, you can calculate equivalent mass as well. How exactly? Try to understand. The reaction is something like this. FeC2O4, it gives what? It gives Fe tripositive plus it gives carbon dioxide. Now, my dear students, you tell me one thing. What is the oxidation state of iron here? It will be +2. When you calculate the oxidation state of carbon, it will be +3. Here, it's going to be +3. Here, it's going to be +4. Now, if you look carefully, +2 to +3, increase in the oxidation state. +3 to +4, again increase in the oxidation state. So, can I say oxidation state of both the elements? Oxidation state of both the elements is increasing simultaneously. And whenever oxidation state of both the elements increases simultaneously or decreases simultaneously, the N factor of the overall species is calculated as N1 plus N2. Let me repeat. Whenever you see a compound wherein oxidation state of more than one element increases simultaneously or decreases simultaneously, its N factor is nothing but N1 plus N2. How do we get N1? How do we get N2? Let's have a look. +2 to +3. What is the change in the oxidation state? +2 to +3. Change in oxidation state. Final minus initial. The value is 1. 1 is the change for one atom. I have only one. So 1 into 1 is 1. +3 to +4. What is the change? Final minus initial. The value is 1. 1 is the change for one carbon. I have 2. So N2 value is 2. So 2 plus 1 comes out with 3. So its N factor is simply 3. Understood? Exactly. Moving on to the next one. Similar sort of question. Now you should be in a position to solve this on your own. You should be in a position to solve this on your own. The reaction is Cu2S. And this Cu2S is getting converted into Cu dipositive. And with Cu dipositive, we have got SO2 as well. Now, my dear students, the oxidation state of copper here is +1, sulfur -2, copper +2, sulfur +4. Look carefully. +1 to +2, increase in the oxidation state. -2 to +4, again increase in the oxidation state. So its N factor, I would say, directly will be N1 plus N2. Now, what do we need? We need to calculate N1 value and N2 value. We need to calculate N1 value and N2 value. How do I do that? See, +1 to +2. +1 to +2. What is the change in oxidation state? Final minus initial. The value is 1. 1 is the change for one atom. I have 2. So 1 into 2 is 2. right? Minus 2 to plus 4. What is the change in oxidation state? Final minus initial. The value is 6. 6 is the change for one atom. I have only one. So N2 value is 6. So 6 plus 2 comes out to be 8. So its N factor is going to be 8. And if you got its N factor, you can easily calculate its equivalent mass. How? Molar mass divided by N factor. That's all. Understood? If you understood this, people, moving on to the next one. What do you think about this one? What do you think about this one? A different question. A reaction that's given to me is Br2 gives BrO3 negative plus Br negative. This is the reaction. Now, if I ask you the oxidation state of bromine here, it is 0. Here, bromine will be in plus 5 oxidation state. Here, bromine will be in minus 1 oxidation state. Now, you tell me just one thing. 0 to plus 5, increase in the oxidation state. 0 to minus 1, decrease in the oxidation state. So, can I say oxidation state of same element is increasing as well as decreasing? If oxidation state of same element increases as well as decreases simultaneously, we say the species undergoes disproportionation, and that particular species which undergoes disproportionation, how do I calculate its N factor? Its N factor formula is N1, N2 divided by N1 plus N2. Okay, now get me the value of N1 and N2. Have a look. 0 to plus 5. What is the change? Final minus initial. The value is 5. 5 is the change for one atom. I have 2. So 5 to 10. So N1 value is 10. 0 to minus 1. 0 to minus 1. What is the change? Final minus initial. The value is 1. 1 is the change for one atom. I have 2. So N2 value is 2. So it is going to be 10 multiplied by 2 divided by 10 plus 2. The value comes out to be 20 by 12. 20 by 12 is nothing but 5 by 3. So N factor of Br2 here will be 5 by 3. Understood, people? If you understood this question, then again, these are your frequently asked. See, this question is asked 3 times. NEET 2018, AIEEE 2013, JEE 2021. So these sort of questions they are asking almost every year. So tell me, what is the answer of this question? Quick, people. Everybody. Everybody in the chats. Quick. Quickly, everyone. Lakshay, you can consult these sessions. They'll be super beneficial for you. See, guys, what do we have to check? We have to get the stoichiometric coefficients. See, first of all, if you look at the reaction is something like this. MnO4 negative plus C2O4 di negative. It gives what? It gives carbon dioxide. With carbon dioxide, you get Mn di positive as well. Well, I did not add H positive and water. They'll get added on its own. How exactly? Try to understand. I've given you the tricks to balance the reaction in those short sessions, which I posted already. I hope you know. See, guys, what do we do? First of all, calculate the N factor of MnO4 negative. See, manganese here in plus 7. Here manganese in plus 2. Plus 7 to plus 2. Change is 5. So its N factor is 5. Carbon here in plus 3. Carbon here in plus 4. So plus 3 to plus 4. Change is 1. 1 is the change for 1. I have 2. Right? So I got the N factors. I got the N factors of reactants and products. My dear students, after getting the N factors of reactants and products, we are supposed to crisscross them. Crisscross means this 2 comes here, this 5 comes here. Now, after crisscrossing them, balance all the atoms except hydrogen and oxygen. 2 manganese here, so 2 manganese on this side. 5 2s are 10. 10 carbon here, so 10 carbon here. Perfect till here? Now, balance oxygen with the help of water molecules. How many oxygen we have on left side? 4 2s are 8 plus 5 4s are 20. So we have got 28 oxygen atoms on this side. 10 2s are 20. 20 oxygen atoms on this side. Which side is oxygen deficient? Right side. How many oxygen deficiencies? 8. So add 8 water molecules on this side. Which side is oxygen deficient? Okay. Now, balance hydrogen. How many hydrogens do you see here? 8 2s are 16. Is there any hydrogen here? No. Add 16 H positives on this side. Now the reaction is balanced. So oxygen is balanced with the help of water molecules, and hydrogen is balanced with the help of H positives. Right? Now we can match the option and you are done. You are done. What about this one, people? The question is, what volume of 0.2 molar K2Cr2O7 is required to oxidize 50 ml of something sodium oxalate? So as far as the question is concerned, K2Cr2O7 is going to react with sodium oxalate. In which medium? In acidic medium. K2Cr2O7. Just a second, guys. Is my number hacked or something? I'm getting a lot of OTPs. My God, what is happening? What is happening? I think somebody has hacked my... I got OTP from... Your OTP is something from DST. Your OTP from Alan. Your OTP from Jeep. Your OTP from something IND. Your OTP from Maruti Suzuki. Wow. Your OTP from GeoNet. Something is wrong, yeah? Again, your OTP from Jeep. Like, have you ever faced this sort of a thing? Is it normal? Is it normal? I'm asking you. I don't know. I'm really bad when it comes to technology and stuff. Lot of OTPs I got. But who do I share it with? I hope nothing happens to my bank balance. Yeah, rest everything I can afford. Yeah, again, guys, something is really wrong. I'm telling you. Bharat loan. This is your verification code, dude. What have I done? All right, let's move on. Chalo, let's move on now. Leave it. Leave it. Leave it. Have a look now. As far as the question is concerned, your K2Cr2O7 is going to react with sodium oxalate in acidic medium. Now, the question is what volume of 0.2 molar K2Cr2O7? The molarity of K2Cr2O7 is 0.2. Its volume I'm supposed to calculate. What is the molarity of sodium oxalate that's given to me? 0.3. And its volume is given to me. How much? Its volume is given to me as 50 ml. If I ask you what is the N factor of K2Cr2O7 in acidic medium? N factor of K2Cr2O7 in acidic medium is 6. Similarly, what is the N factor of sodium oxalate? Sodium oxalate's N factor will be 2. Now, molarity multiplied by N factor, that gives me normality. So, normality will be 6 into 0.2, that's 1.2. And normality here will be, normality here will be 0.3 into 2, that will be 0.6. Now, what I can do? As per equivalent concept, as per law of equivalence, I can say milli-equivalence of K2Cr2O7 reacted has to be equal to milli-equivalence of sodium oxalate reacted. Milli-equivalence of potassium dichromate will be equal to normality of 1 multiplied by volume of 1 in ml. Similarly, milli-equivalence of second will be normality of second multiplied by volume of second in ml. Right? So what is normality of 1? That is 1.2. Volume of 1 needs to be calculated. Normality of 2, 0.6. Volume of 2, that is 50 ml. So this will be 1, this will be 2. 50 divided by 2 is 25. So V1 is 25 ml. Right? Okay, guys. Let's move on to the next question. Let's move on to the next chapter. Next chapter will be your atomic structure. So tell me first of all, I'm coming in the reverse manner in atomic structure. Reverse manner. So tell me, what is it? Done? Done, people? It's a quick one. It's a quick one. See, first of all, I have to check which of the following is not permissible. Which of the following is not permissible. I hope you know, N represents your principal quantum number. L represents azimuthal quantum number, whose value is from 0 to n minus 1. I hope you know that. And magnetic quantum number, M, its value is from minus L to plus L, right? And spin can have two values, either minus 1 by 2 or plus 1 by 2. This is something which I believe every one of you would be knowing, right? Now, at the same time, what is the value of L for S? For S subshell, the value of L is 0. For P subshell, the value of L is 1. For D subshell, the value of L is 2. For F subshell, the value of L is 3. This is the L value. Okay, this is the L value. Now, my dear students, try to understand. Try to understand carefully. N is equal to 5. N can be 5, fifth shell. L is equal to 3. L value is from 0 to n minus 1. So 0 to 5 minus 1. So 0 to 4. So it can be 0, 1, 2, 3, 4. Correct? M is 0. M is from minus L to plus L. So M can be minus 3, minus 2, minus 1, 0, 1, 2, 3. Right? S can be either plus 1 by 2 or minus. This is correct one. This is correct one. So which one do I think is incorrect? I think the second one is incorrect. Why is that? I think the second one is incorrect. See, N value is 3 here. L value is 2. But M is from minus L to plus L. Minus 2 to plus 2. Minus 2 to plus 2. It cannot be minus 3. So this one is the answer of the question. This is the incorrect one. This is the incorrect one. Chalo, moving on to the next one. What do you think about this one? The correct set of 4 quantum numbers for the valence shell of rubidium. Rubidium. Lithium, sodium, potassium, rubidium, cesium, right? Lithium, sodium, potassium, rubidium, cesium. If you know what is the outermost configuration of lithium, it is 2s1. Sodium is 3s1. This is 4s1. This is 5s1. So the outermost electron is in 5s in case of rubidium. So when I talk about 5s1, this electron, it belongs to shell number 5. It belongs to shell number 5. For S subshell, the value of L is 0. The value of L is 0. If L is 0, M will be also 0 because M is from minus L to plus L. S can be either plus 1 by 2 or minus 1 by 2. Right? Do you see any option like this? 500 plus 1 by 2. 500 plus 1 by 2. 500 plus 1 by 2. Option C. Done? Done, people? I believe yes. Okay. Tell me the answer of this question. I've given these shortcuts already in those small sessions which I gave you. Quick. The orbital angular moment of p electron. Orbital angular moment of p. What is the L value for p? L value for p is 1. Orbital angular momentum formula is equal to under root of L into L plus 1 multiplied by h upon 2 pi. What is the L value? L value is 1. So 1 into 1 plus 1. That's root 2 h upon 2 pi. Right? So it's going to be finally h upon root 2 pi. H upon root 2 pi. Yeah? A. Done? Majority has already given A. Correct? Good one. Nice. Tell me the answer of this one. The orientation of atomic orbital is given by which quantum number? Orientation of atomic orbital is given by magnetic quantum number. This I believe everyone would be knowing. Right? Your principal quantum number, it gives the information about the size, energy of the shell. Similarly, your magnetic quantum number, it gives me the idea about the orientation. It gives me the idea about the orientation. Anyways, moving ahead. 4D, 5P, 5F, 6P are arranged in the order of decreasing energy. I have to arrange them on the basis of decreasing energy. So, the rule is N plus L rule. The rule is N plus L. What is the N value here? 5. L value for F. So, first of all, I'm talking about 5F. For 5F, N value is 5. And what is the L value? SPDF. L value is 2. So, N plus L. 5 plus 2 is 7. 5 plus 2 is 7. Similarly, 6P. Similarly, 6P. N value is 6. In case of P, the value of L is 1. So 6 plus 1 is again 7. Right? Similarly, 5P. N value is 5. For P, L value is 1. So 5 plus 1 is 6. 4D. 4D. N value is 4. For D, SPD. SPD. L value is 2. So 4 plus 2 is 6. Right? More the N plus L value, more the energy. More the N plus L value, more the energy. So these two will be having more energy than that of these two. Now, among these two, since they have same N plus L, so decide on the basis of N. So among these two, decide on the basis of N. The one that has lesser N value has got lesser energy. Right? Among these two, the one that has got lesser N value has got lesser energy. I have to arrange them on the basis of decreasing order. Decreasing order will be 6P will have maximum energy. 6p will be our maximum energy, followed by 5f, followed by among these two, which has maximum n value 5p. So it's 5p, and at the end it's going to be 4d, right? Check. That's going to be the correct one. Okay, this sort of a question is pretty much simple. Tell me the answer of this one. Orbital having 3 angular nodes and 3 total nodes. Do you know how do we calculate total number of nodes? Total number of nodes is given by the formula n minus 1. Okay, these total nodes are basically of 2 types. One is called as radial or spherical nodes. Second one is called as angular nodes. Angular node is represented by L value. This is n minus L minus 1. N minus L minus 1. Okay, n minus L minus 1. Now tell me. Orbital having 3 angular nodes and 3 total nodes. So n minus 1 is 3. If n minus 1 is 3, that means n value is equal to 4. I think there is only one option with n4, so it has to be option D. Right? It has to be option D. I believe I'm clear with this. And if I'm clear, then move on to the next one. This is psi square versus R graph. And the graph is starting from the top. So it has to be for S. It will be for S. Now which S? Have a look. How many nodes do you see? 1 node. So n minus 1 is equal to 1. So total number of nodes is equal to 1. So this is the node here. So n minus 1 is equal to 1. So n value will be 2. And those graphs which start from top, when it comes to psi versus R or psi square versus R, they are from S. So it is basically your 2S. It is basically your 2S. Right? Done and dusted? Okay. If this is done and dusted, tell me the answer of this question. If the uncertainty in the position and momentum are equal, if the uncertainty in the position and momentum are equal, then uncertainty in the velocity will be. What do you think about this one? Goodness. Oh, goodness. Oh my goodness. Is it fine now? Is it fine now? It was lagging. I think my data pack got over. Can you check once? Is it fine? Say yes, yes quickly in the chats. Yes, no quickly in the chats. Is it fine now? Is it fine now? Quickly. Perfect. All right. So what do you think is the answer of this question? My dear students, delta x is equal to delta p. If delta x is equal to delta p, I can write it as delta p ka square is equal to h upon 4 pi. Right? Delta p ka square is equal to h upon 4 pi. Delta p is nothing but m delta v. Right? So m delta v ka square, which can be equal to under root of h upon 4 pi. So I can say this can be written as 1 divided by 2 under root of h upon pi. Right? Take this m in the denominator. So I can say delta v is equal to 1 divided by 2m, and it's going to be under root of h upon pi. Do you see any option like this? 1 upon m under root of h by pi. So it has to be option A. That will be the correct answer. Okay, that will be the correct answer. Now, similarly, my dear students, let's move on to the next one. This question, without solving, you should be in a position to tell me. Without solving. Without solving, I'm telling you. A stream of electrons from heated this, that, calculate h upon lambda. Calculate h upon lambda. Have you heard about this equation? Lambda is equal to h upon under root of 2m ev. In physics, in chemistry, we derive this result. In physics as well as chemistry, we derive this result. You should be knowing. So, h divided by lambda. H divided by lambda will be equal to root of 2m ev. So, this is the answer. I'm not solving this because this result, every one of you, I believe, would be knowing already. Okay, if this is done, what do you think about this one? The de Broglie's wavelength associated with the photoelectron varies with the frequency, something like this, that. Tell me, what do you think? Quickly, guys, I'm looking at your chats. This has been asked in your JEE mains as well. The same question. See, you know, lambda is equal to h upon p. This is something every one of you would be knowing, right? Now, one more result which all of you will be knowing. I think you know kinetic energy is equal to p square by 2m, right? So I can say p is equal to under root of 2m multiplied by kinetic energy. So I can say it is equal to h upon under root of 2m multiplied by kinetic energy, right? Now, as per your photoelectric equation is concerned, incident energy is equal to work function plus maximum kinetic energy, right? Incident energy is equal to h nu. This is equal to h nu naught plus Ke max. So from here, I can calculate Ke. Ke will be equal to, if I take h common, it's going to be nu minus nu naught. So replace here Ke. So it's going to be h divided by under root of 2m. Instead of Ke, I'll write h multiplied by nu minus nu naught, right? Now see, your lambda and nu minus nu naught. So I'll say lambda is inversely proportional to nu minus nu naught raised power 1 by 2 because it's a root here. Do you see any option like this? I think last one. Yeah. Last one is right. These sort of questions you do in physics as well. I believe I'm clear with this. And if I'm clear with this, tell me the answer of this question as well. When an electron is excited from ground level to 5th orbit, lower energy state is equal to 1, higher energy state is equal to 5, right? Number of spectral lines. How do I calculate number of spectral lines? Number of spectral lines is equal to n2 minus n1 multiplied by n2 minus n1 plus 1 divided by 2. Now tell me n2 minus n1. So 5 minus 1 is 4, right? 5 minus 1 plus 1 divided by 2. So this gets cancelled. 5 for 20, 20 divided by 2 is 10. So total spectral lines here is equal to 10. Got it? Got it, people? I believe I'm clear with this. The next question. What is the maximum wavelength in case of Balmer series? Maximum wavelength. You know, delta E is inversely proportional to lambda. For lambda to be maximum, delta E has to be minimum. Now, in case of Balmer, when is the energy gap minimum? In case of Balmer, the energy gap is minimum when the electron makes a transition from 3 to 2. Lower energy state here is N1, higher energy state is N2. So, as per formula, 1 divided by lambda is equal to R, Z square. Let Z value is 1. 1 upon N1 square, 2 ka square is 4, minus 1 upon N2 square, 3 ka square is 9. So, 1 divided by lambda is equal to R. It's going to be 9 minus 4, 5. Divided by 36, right? So lambda is equal to 36 divided by 5 into 1 by R. 1 by R, you know, that is 911.5 angstroms. So solve this, the answer is going to be in angstroms. Then you can convert this into nanometers as well. Guys, do you understand? Am I clear? When you solve this, the answer is going to be this one. I've shown in those short sessions, those 50 concept questions. Right? Those 50 concept questions. I've shown you these sort. I've shown you these sort. Simple. Quickly, people. Is it clear? Tell me the answer of this one. Tell me the answer of this one, my dear students. Quick. I hope you remember I have given you the result already. R1 divided by R2 is equal to N1 square divided by N2 square multiplied by Z2 divided by Z1. Do you remember? Do you remember? Do you remember, people? So it's pretty much simple. We are given with He positive ion on one side, and on another side we have got Be tripositive. Be tripositive. Hydrogen, helium. Atomic number is 2, right? Calculate the radius ratio of second orbit. So N1 is 2. Okay, let's radius is R1. Similarly, beryllium, hydrogen, helium, lithium, beryllium. So Z2 value is 4. N2 value, it's third orbit. And let its radius be R2. So I just need to calculate this. N1 ka square, 2 ka square is 4. N2 ka square, 3 ka square is 9. Z2 is what? 4. Z1 is 2. Right? 2, 1. 2, 2. 4 to 8. 8 by 9. So 8 is to 9 is the radius ratio. Simple. I hope you would be in a position to solve this one as well. Tell me the answer of this one. Tell me the answer of this one. Energy and N, something. You know the formula. Energy of nth Bohr's orbit is equal to minus 13.6 Z square divided by N square. Similarly, you know the radius of nth Bohr's orbit is equal to R naught N square divided by Z. These are the formulas. If you know the formula for velocity, velocity of the electron is equal to V naught Z divided by N. Time period of electron is equal to T naught N cube upon Z square. Similarly, frequency, directly proportional to Z square, inversely proportional to N cube. Now tell me the answer. Match them. Energy and N square, inversely, correct? Radius and N square, directly. Radius and N square, directly. Energy and N square, inversely. So option B. Guys, is it clear? Is it clear? Say it in the chats once. Is it clear? Tell me, which of the following series of transitions in the spectrum of hydrogen falls invisible? You have got Lyman. You have got Balmer. Okay, here they are mentioned already. Lyman, Balmer, Paschen, bracket, and here it's Fund. Perfect. Remember, this is ultraviolet. This is visible. This is infrared. This is infrared. This also infrared. Or sometimes you can say this is far infrared. This is far infrared. Okay, remember that. Remember it. Remember it, people. Tell me the answer of this one. Energies E1 and E2 of two radiations, 25 electron volts and 50 electron volts. The relation between their wavelengths, lambda 1. You know, your delta E, or you can say E is inversely proportional to lambda. E is equal to hc by lambda. So E is inversely proportional to lambda, right? So I can say E1 divided by E2 is equal to lambda 2 divided by lambda 1. Okay, so this is 25 divided by 50 is equal to lambda 2 divided by lambda 1. So this is 1, this is 2. I can say lambda 1 is equal to 2 times lambda 2. Lambda 1 is equal to 2 times lambda 2. Done and dusted. Right? Am I clear, guys? Guys, I'm getting calls also. Your one-time password is this. What is wrong? What is wrong? Should not be hacked or something. I hope, I pray to God. It should not get hacked, guys. I'm not opening any message. Did I get any message from the bank? Your account has been debited for this much. No, right? No, nothing like that. Okay. Chalo, let's move on. Don't sleep. Let's move on. Thermodynamics, my favorite chapter. Tell me, people. What do you think? What do you think? The first question on your screen. Quick, my throat already started burning. Quick, people. Quick. Internal energy, boiling point, pH. Internal energy is the example of extensive property. Boiling point is the example of intensive property. pH is the example of intensive property. EMF is the example of intensive property. Right? See, extensive properties are size dependent. Intensive properties are size independent. Right? So which one is going to be? You can check the option. Tell me, molar entropy and temperature are. Molar entropy and temperature are. Temperature is intensive. So this has to be intensive as well because they are mentioned and. Okay, it's molar entropy basically. It's entropy per unit mole. Entropy itself is extensive. But extensive property expressed per unit mole becomes intensive. So both are intensive properties. Both are intensive properties. Right? Which of the following are not the state functions? Your state functions are pressure, volume, temperature, internal energy, enthalpy, entropy, Gibbs free energy. 1, 2, 3, 4, 5, 6, 7. Yeah. These are your state functions. These are your state functions. Okay. Now Q plus W is internal energy. H minus Ts is Gibbs free energy. So this is state function. This is state function. Q and W, these are path functions. Q and W, these are path functions. So the answer is 2 and 3. Which are not state functions means which are path functions. So path functions is heat and work. Right? Yeah? Majority is given the correct answer already. Great. Tell me the answer of this question. When freezing of liquid takes place, tell me one thing. When liquid freezes, think about it. When liquid is frozen, when liquid freezes, heat is absorbed or heat is released. When liquid freezes, heat is released. And when heat is released by the system, Q value is taken to be negative. So Q is taken to be negative. Here is the option. Yes. Done. 3 moles of ideal gas expanded spontaneously in vacuum. They have mentioned vacuum. Expansion in vacuum is called as free expansion. Expansion in vacuum is called as free expansion. And when it comes to free expansion, work done is always 0. When it comes to free expansion, work done is always 0. Right? Nothing to think. Yeah? Direct questions. Area under PV curve gives us the magnitude of work. So if you look in path 1, this is the area under path 1. This is the area under path 2. This is the area under path 3. So area under path 3 is more. That means magnitude of W3 is greater than that of magnitude of W2 is greater than that of magnitude of W1. That's the question. That was the answer. W3, W2, W1. So, simple. Right? Absolutely. The next one. A very difficult question this is. What do you think about this one? Quick. Quick, people, quick, everyone. Do you see anywhere mentioned P external 0? P external 0, that means vacuum. P external 0, that means free expansion, right? In free expansion, P external is 0. And whenever there is free expansion, work done is always 0. I'm not reading the question. Leave it. Yeah? You have to be careful with these small things. These are small basic questions. Chalo, this is a simple question. It's a easy kill question, I would say. An ideal gas is allowed to expand from 1 liter to 10 liters against a constant external pressure. Against a constant external pressure of 1 bar. When external pressure is constant, we call the process irreversible. Work done. How do we calculate work done in irreversible process? Minus P external delta V, which is V2 minus V1. So P external is how much? 1 bar. V2 is 10. V1 is 1. The value comes out to be minus 9 and its units are bar liter. Do I need the answer in bar liter or joules? I need the answer in kilojoules. Remember, 1 bar liter is equal to 100 joules, but I need it in kilojoules. So divide it with 1000. The answer comes in kilojoules, right? So it's going to be minus 0.9 kilojoules. Yes? Perfectly done. Absolutely. Moving on to the next one. The molar heat capacity of water at constant pressure is given to me as 75 joules per Kelvin per mole. When 1 kilojoule of heat is supplied, to 100 grams of water. Okay, we have got 100 grams of water. 100 grams of water means how many moles of water? It means mass of water divided by molar mass. So we have got 5.5 moles of water. We are supplying 1 kilojoule. 1 kilojoule means 1000 joules. We are supplying 1000 joules of heat to 5.5 moles of water. When heat is supplied to the system, Q value is taken as positive, right? So when you supply this much of heat to 5.5 moles of water, definitely temperature of water is going to raise. Definitely temperature of water is going to raise, right? We have to calculate a raise in temperature, delta T. Delta T needs to be calculated. I hope you would have heard about one formula. Your Q is equal to NCP delta T. So calculate delta T here. Delta T is Q divided by N and CP. Q is how much? 1000. N is how much? 5.5. CP is how much? 75. When you solve, the answer will come out to be 2.4 Kelvin. Right? Am I clear, people? A simple question this again. Okay. Look at this one. Quickly. In a closed insulated container, they have mentioned closed insulated container. Insulate means Q is equal to 0. A liquid is stirred with a paddle to increase the temperature. Which of the following is true? First of all, Q is equal to 0. If Q is 0, first law says that delta U is equal to Q plus W. Now, if Q is 0, that means delta U is equal to W. Delta U is equal to W. Q is equal to 0. Q is not equal to 0, not equal to 0, not equal to 0. So I'll go directly with 1. I'll directly go with option number 1. Yeah? Done and dusted. During compression of a spring, we are compressing a spring. If I'm compressing the spring, is work done on the system or work done by the system? I'm compressing the spring. Work is done on the system. And whenever work is done on the system, W value is taken as positive. So how much? It is plus 10 kilojoules. Now, 2 kilojoules escaped. 2 kilojoules escaped to the surroundings as heat. 2 kilojoules escaped to the surroundings as heat. That means heat is released by the system. And when heat is released by the system, Q value is taken as negative. How much? Minus 2 kilojoules. Now, you know W, you know Q. What do I have to calculate? Delta U. Delta U is equal to Q plus W, right? Q is minus 2, W is 10. So the value is going to be 8 kilojoules. So this is the value of delta U. Am I clear? Am I clear, people? Am I clear? Yeah? Okay. Perfectly done. Let me move on to the next question. The question is delta U is equal to isochoric. This is also long back asked in your JEE Mains examination. Delta U is equal to isochoric work, isobaric work, adiabatic work, isothermal work. My dear students, you know, as per your first law of thermodynamics, delta U is equal to Q plus W. Tell me one thing. When will be delta U equal to W? Delta U will be equal to W when Q is 0. So delta U will be equal to W when Q is 0. Q is equal to 0 means adiabatic. That means delta U is equal to adiabatic work. Delta U is equal to adiabatic work. Yeah? No, it's not isothermal. You have to be careful with the questions, guys. It is adiabatic, right? I knew majority of the students will either go with isochoric or isothermal. Be careful. These are small mistakes which you can commit in the exam. You have to be careful. Okay, what do you think is the answer of this question? When 1 mole of the gas is heated at constant volume, they have mentioned constant volume. That means W is 0. Okay. Temperature raised from something to something. If heat is supplied to the gas, whenever heat is supplied to the gas, Q value is taken as positive. So heat is absorbed by the system, right? In which of the following is correct? So first of all, W is equal to 0. As per first law, delta U is equal to Q plus W. Now W is 0. That means delta U is equal to Q. Delta U is equal to Q. And Q is how much? Q is 500. Now look at the options. Look at the options. W is equal to 0. Where is W 0? Here W is 0. Delta U is equal to Q. Delta U is equal to Q. So option 2 is the correct one. Yeah? Perfectly done? Perfectly done? For the reaction, a reaction is given. We have to calculate the value of delta H minus delta U. It is basically delta U here. You know, your delta H is equal to delta U plus delta NGRT, right? So I would say delta H minus delta U is equal to delta NGRT. We have to calculate this term. Delta H minus delta U. Delta H minus delta U is equal to delta NGRT. First of all, calculate delta Ng for the reaction. Delta Ng for the reaction is equal to number of moles of gaseous product. Number of moles of gaseous product, that's only 3. Minus number of moles of gaseous reactant, which is 5 plus 1, 6. So 3 minus 6 comes out to be minus 3. So it's going to be minus 3 into R into T. Do you see any option like that? Minus 3 RT? Yes, I'll go with option 3. Perfect? Absolutely. Moving on to the next one. Moving on to the next one, people. Moving on to the next one. Look at this question. Calculate the work done in joules when 4.5 grams. 4.5 grams of H2O2 means how many moles of H2O2? Mass of H2O2 divided by molar mass. Molar mass of H2O is 34. So it will be how much? 4.5. 4.5 is 9, right? Can you check how much this value will be? 4.5 divided by 34? Almost 1 by 7, huh? Let me exactly get the value. 4.5. Let me use the calculator quickly. 4.5 divided by 34. It is 0.132. 0.13. So these are the moles of H2O2 which we have. What do we have to calculate? Work. What do you have to calculate? Work, right? Do you know any formula like this? W is equal to minus delta NGRT. Yes, you should be knowing, right? Delta Ng for the reaction is equal to number of moles of gaseous product. That's 1. So W is equal to minus delta Ng is 1. Do I have to calculate answer in joules or calories? Answer has to be in joules. So our value has to be 8.314. Temperature is how much? 25 degrees centigrade. That means 298 Kelvin. So this is the value of W in joules. But this is not the answer of the question. Why is that? This is the value of W. This is the value of W when we do the decomposition of 2 moles of H2O2. So when we do the decomposition of 2 moles of H2O2, this is the value of W. How much? Minus 8.314 into 298. Therefore, when we do the decomposition of 1 mole of H2O2, what would be the value of W? It will be minus 8.314 into 298 divided by 2 joules. As per the question is concerned, do we have to do the decomposition of 1 mole H2O2? No. We have to do the decomposition of 0.13 moles of H2O2. So when 0.13 moles of H2O2 undergoes decomposition, it will be minus 8.314 into 298 divided by 2 multiplied by 0.13 joules. So this is the final answer. You have to do a bit of calculation here. That's all. Am I clear? All right, people. This sort of a question you can solve like this. Okay. A simple question. Delta H, delta U. Tell me one thing. What is the value of delta Ng for the reaction? Delta Ng is number of moles of gaseous product. That is 2. Gaseous reactant. That's 1. So 2 minus 1 is 1. You know, delta H is equal to delta U plus delta Ng RT. So I would say delta H is equal to delta U plus RT. Why? Because delta Ng is 0. So I can clearly say delta H is greater than delta U. Basically, you are adding this term. You are adding this term to delta U. You are adding this term to delta U. Then it gets equal to delta H. You are adding this term to delta U. Then it gets equal to delta H. So I would say delta H is greater than delta U. So option 2 is the correct answer. Yeah? Am I clear, people? Everyone? Right? Are we done with this? Okay. Moving on to the next one. 1 mole of non-ideal gas undergoes a change in state from this to this, okay? With the change in internal energy delta U is given, the change in enthalpy delta H we have to calculate. So see guys, understand. This is the initial pressure of the gas P1, initial volume, initial temperature. Final pressure, final volume, final temperature. So pressure of the gas is changing, volume of the gas is changing. When pressure as well as volume of the gas both change, delta H is equal to delta U plus, it becomes P2V2 minus P1V1. This is the formula which we use. When pressure and volume both change, then we say delta H is equal to delta U plus P2 V2 minus P1 V1. So I would say delta H is equal to, what is delta U? 30 atm liter. What is P2 into V2? 5 4s are 20 minus P1 into V1. 3 2s are 6. So this is 14. So the answer comes out to be 44 atm liter. Do you see any option like this? The question was asked long back in JEE Advanced. This one, same question. And it was a simple one. All right. What about this one? What about this one, people? Quick, 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 everyone in the chats. My dear students, do you see somewhere mentioned as isothermal? Ideal gas is undergoing isothermal process. And you should know when ideal gas undergoes isothermal process, delta U as well as delta H, both are 0. Correct? Now, if delta U is equal to 0, that means Q plus W is 0, which means that Q is equal to minus W. Q is equal to minus W, right? Q is equal to minus W. Now tell me one thing. Q is equal to minus W. You would have what one thing? Is the gas undergoing expansion or compression? Pressure of the gas is decreasing. If pressure is decreasing, that means gas is undergoing expansion. You would have studied one thing. When an ideal gas undergoes isothermal expansion, when an ideal gas undergoes isothermal expansion, heat is absorbed by the gas. Do you know? When an ideal gas undergoes isothermal expansion, heat is absorbed by the gas. So Q has to be positive. Q has to be positive. If Q is positive, W has to be negative. So delta U, delta H, both are 0. We know that already, right? Now, Q has to be positive. Q has to be positive. W has to be negative. So without solving, I'm opting for 1. Without solving, I'm opting 1. Right? Did you see how? Just one statement I remember. Whenever an ideal gas undergoes an isothermal expansion, whenever an ideal gas undergoes an isothermal expansion, heat is absorbed by the gas. If heat is absorbed, that means Q value is negative. Sorry, if heat is absorbed, as per sign convention, Q value is positive. If Q is positive, automatically W becomes negative. So no need to solve the question. You're done by just looking at it. If you want to solve also, you can do that. W is equal to minus 2.303 nRT log of P1 divided by P2. You can do the calculation and you'll get the answer. All right. Something which I was telling you right now. During isothermal expansion of an ideal gas, what happens? What happens? Heat is absorbed by the gas. To keep the internal energy constant. First of all, during isothermal expansion of an ideal gas, isothermal means temperature remains constant. Temperature remaining constant means internal energy is constant, means enthalpy is constant. So this cannot be the answer. This cannot be the answer. Enthalpy remains unaffected. This is correct. This cannot be the answer. Okay. Basically, when ideal gas undergoes isothermal expansion, heat is absorbed by the gas. Why? Just to keep its internal energy constant so that its temperature remains constant. You should know one thing. For an ideal gas, internal energy is the function of temperature. And enthalpy is also the function of temperature. For which gas? For ideal gas. For ideal gas. Now we are talking about isothermal process. Isothermal means temperature constant. So if temperature is not changing, internal energy of the gas will not change. Enthalpy of the gas will not change. Simple. Yeah? Done, people? Okay. What about this one? Adiabatic expansion. This is also something which you would have studied in thermodynamics. Whenever an ideal gas undergoes adiabatic expansion, internal energy of the gas decreases. Temperature of the gas decreases. That means gas undergoes cooling. I hope you would have studied this. If not, you know, delta U is equal to Q plus W. Correct? Adiabatic process means Q is 0. So delta U is equal to W. Now they are talking about what? Expansion. expansion means W is equal to negative. If W is equal to negative, that means delta U is negative. If delta U is negative, that means internal energy of the system decreases. If internal energy decreases, so temperature of the system also decreases. Simple. Delta U negative means internal energy decreasing during the expansion. Temperature of the system also decreasing during the expansion. So, get the answer? Decrease in the internal energy. Yes? What about this one? The correct option for the free expansion of an ideal gas under adiabatic. So first of all, they have mentioned free expansion. Free expansion means W0. At the same time, they have mentioned ideal gas undergoing adiabatic. Adiabatic means Q0. Now tell me, W0, Q0. As per first law, delta U is equal to Q plus W. Both are 0. So delta U is 0. If delta U is equal to 0 for an ideal gas, that means NCV delta T is 0, which means delta T value has to be 0. Now find the options. Find the options. Find the options. Q0, everything 0. So which one is the correct one? Yes, this one, option 4. Right? Right. Option number 4. Chalo, moving on to the next one. In case of the cyclic process, what happens in cyclic process? System returns to its initial state. System returns to its initial state after going through a lot of steps, right? And you know, in case of cyclic process, change in the value of any state function is equal to 0. You can say delta U net is equal to 0, delta H net is equal to 0, delta G net is equal to 0. All are state functions. All of these are state functions. This is a path function. So this is the final answer. This is the incorrect one. Change in the value of state function is 0. Change in the value of state function is 0. And this is state function, this is state function, this is state function. This is a path function, W. Right? So this is the incorrect one. Was I supposed to find the incorrect one? Yes. Okay, all right. Chalo, moving on to the next one. In which case change in entropy is negative? Evaporation of water. Evaporation of water. When you evaporate water, so liquid you are converting into gas. If you are converting liquid into gas, disorder will be increasing. Disorder increasing means entropy increasing. So entropy is increasing. So delta S is positive in this process. We have to check delta S negative, okay? All right. Okay, I can find the last option directly. Check. 2H gas. It gives H2 gas. Stoichiometric option 2. Here 1. So moles are decreasing. Moles are decreasing. That means particles are decreasing. Particles decreasing means disorder decreasing. Disorder decreasing means entropy decreasing. Entropy decreasing means delta S negative. So this is the process wherein delta S is negative. Okay. All right. What do you think about this one? The process with negative entropy change. Synthesis of ammonia from N2 and H2. So it is going to be reaction is going to be N2 plus 3 times H2. It gives 2 times NH3. See, all the reactants products are in gaseous phase. So on reactant side, how many moles we have? 4. On product side, 2. So during this process, moles are decreasing. Gaseous moles are decreasing. If moles are decreasing, that means particles are decreasing. Particles decreasing, disorder decreasing, disorder decreasing, entropy decreasing, entropy decreasing, delta S negative. So delta S negative in the first case only. In all the other cases, you can check, it will be positive. Yeah? Okay. Thermodynamic parameter, the criteria for spontaneity. Now tell me one thing. If entropy is the only criteria, to check whether the process is spontaneous or not. Remember, if entropy is the sole criteria to decide whether the process is spontaneous or not, then remember, delta S total has to be greater than 0. Then only we say the process is spontaneous and at the same time irreversible, right? Delta S total means delta S system plus delta S surrounding. Delta S total means delta S universe, which is nothing but delta S system plus delta S surrounding. It has to be greater than 0. And you know, if delta S total is negative, that means system plus surrounding. If it is negative, the process is non-spontaneous, right? And if delta S total is equal to 0, we say that is the equilibrium condition, reversible condition. So the answer is option A, for the process to be spontaneous. Yeah? Similarly, guys, similarly, look at this question. Where did that go? Where did that go? Okay, this is the question. This was also asked in your J mains. It's a J mains PYQ, and similar sort of questions are asked in your NEET. What do you think? We are given with the reaction, its delta H is given. Okay. Delta S is also given as 2 times T. Minimum temperature at which it will be spontaneous. Calculate the temperature at which the reaction will be spontaneous. Right? Well, first of all, if you look carefully, this is given in kilojoules. This is in joules. So convert kilojoules into joules. So it has to be 80,000 joules basically. Now for any process to be spontaneous, delta G system at pressure temperature should be negative. This is the condition. For any process to be spontaneous, delta G system at constant pressure temperature, that should be negative. Now delta G is nothing but delta H minus T delta S. This has to be negative. What is delta H? Delta H is 80,000 minus T. What is delta S? Delta S is 2 times T. It becomes 2 times T ka square. It has to be negative. So I would say 80,000 is less than 2T square, or I can say 2T square is greater than 80,000, or I can say T square is greater than 40,000, or I can say T has to be greater than 200 Kelvin. So temperature should be greater than 200 Kelvin, then only the process will be spontaneous. Temperature should be greater than 200 Kelvin, then only we can say the process is spontaneous. Am I clear? Let me know once in the chats, my dear students. Am I clear with this? Okay. Got it? King Hasib is giving answers quickly. Mayra Kashur. Jaldi once my chat summons. Machu Kashur. Where Kashur shuk me wan parankait osuk. All clear people till here? Okay. मतलब online ना? Okay. बेकुछ कुछ कशुरेत. आपसे physical किया सारा. Great. Good. I think it's perfectly clear to everyone, yeah? All right. Okay. So I think, guys, the remaining questions I'll be doing in day after tomorrow's session. Day after tomorrow, we have one more session scheduled. Day after tomorrow, we have one more session scheduled. Let me show that to you. Because I cannot drain my throat. You know, it's not in good condition. You know that already, right? This is the session which I'm taking when? Day after tomorrow. Day after tomorrow, on Thursday. 45 short questions. The remaining questions I'll be doing here in this particular short. All right. So there will be short questions as well as the remaining questions of this particular session in this particular one. I hope all of this is like super clear to everyone. Like super clear. One thing which I would want from you in the comment section. What is that? Do let me know exactly how you find this particular session? Was it beneficial? In the comment section or in the chats. And I would want everyone to comment on the session and let me know with your genuine feedback. Like, are these sessions beneficial to you or not at this particular point of time? Do let me in the comment section. I'll check your comments. Okay. Then I'll get to know whether you guys are getting benefited from these sessions or not. Okay. Chalo. Take care. God bless you all. See you day after tomorrow. Till then, you take care. God bless you all and